Hey students, this is our final lecture from section 15.2, which is double integrals over general regions. Now we're not going to get into any really crazy regions. All we're going to deal with is first of all a triangular region, so a triangle, and then for the other one we're going to have something a little bit more complicated involving a trig function. Okay, so for our first example, they want us to integrate f of x, equals x squared plus y squared over the triangular region, okay, over the triangular region with vertices zero, 0, 8, 0, and 0, 8. Okay, so we want to integrate the multivariable function f of x equals x squared plus y squared over the triangular region with vertices 0, 0, 8, 0, and 0, 8. Okay? And since it's not a rectangle, we are going to need to do a sketch of this region, but it shouldn't be too hard to draw. So what we're talking about is with the xy plane, we can just plot these 3 points, and then we can sketch our triangle. So we've got the point 0, 0. Okay, we've got the point 8, 0, where x is 8 and y is 0. And then we have the point 0, 8, where x is 0 and y is 8. And we want to turn a triangle out of that. So let's go ahead and make that into a triangle. Just connecting the dots. Okay, and I think you can do these with either horizontal or vertical cross sections. I think I'm going to do this one with vertical cross sections, but you can also do horizontal. So I'm just going to choose vertical. Okay, so vertical cross sections. Okay. Anyway, we're going to actually have to figure out what this function is up here, what that line is. But since we're doing vertical cross sections, that means we need to solve for y. Okay, so solve for y when we're writing our functions. So then the question is, what is this line right here? How do we figure out what that line is? Well, we can see that with this line, we can see that the y-intercept is actually 8. So since the y-intercept is 8, that's the same as b. So what we can do is we can write down y equals mx plus b. Right, that's the standard form of a line with y-intercept b and slope m. Okay, and then we can figure out what this line is. We know that the y-intercept has to be b, which is 8. Okay, so we're going to have 8 there. And then how do we figure out the rest of the problem? Well, we can figure out the slope of this line by just looking at these 2 points here. So this first point is the point 0, 8, and the second point is the point 8, 0. Okay, so I don't know if you remember the slope formula, but the slope formula says m equals y2 minus y1 over x2 minus x1. So plugging in, we can label x1, y1 is going to be 0, 8, and x2, y2 is going to be 8, 0. So what we got here is 0 minus 8 divided by, sorry, let me write it down here. We've got 0 minus 8 on the top. That's y2 minus y1 divided by x2 minus x1, so that's going to be 8 minus 0. So the slope m is actually going to equal negative 8 over positive 8, which is negative 1. Okay, so our slope m equals negative 1. So that means we have the equation of our line. So the equation of our line is going to be y equals negative 1 times x plus 8. Okay? Alright, so that's going to give us that diagonal line up here. And then since we're doing vertical cross sections, I have that solved for y. So now what does a vertical cross section look like? Well, it starts down here and it goes up there. Starts at the bottom, goes up to the top. And we can see that x is starting at 0 and x is ending at 8. So x has to be between 0 and 8. And then y, well, on the bottom, y is bounded by the x-axis, which is just y equals 0. Okay, so remember that the x-axis is the same as y equals 0, the horizontal line. Okay? And then on the right side, sorry, not the right side, on the top, we have this line here, but we just found the equation of that line. So that line right there is negative x plus 8. So y is between 0, which is the x-axis, and this diagonal line up here, which is going to be negative x plus 8. Okay? And then we're set up for vertical cross sections now, so we just need to write down our double integral. And remember, with vertical cross sections, your inner integral has to be dy. Okay? So our double integral here is going to be the double integral. So the outer integral is going to be in terms of x, so that's going to go from 0 to 8. So from x equals 0 to x equals 8. And then our inner integral is going to be in terms of y, and that's going to be going from 0 to negative x plus 8. Okay, so from y equals 0 to y equals negative x plus 8. Okay, and then our function that we started with was actually x squared plus y squared. So we're doing the double integral of parentheses x squared plus y squared, and our inner integral is dy, and our outer integral is dx. Okay, and as always with double integrals, you want to do your inside integral first. So we're going to do this inner integral first, the dy. Okay, and remember, if you're integrating with respect to y, that means the other variables are constant. So this means x is going to be constant. Okay, so since x is constant, x squared is constant. So the integral of x squared is just going to be x squared times y. Right, because the integral of a constant is the constant times a variable. And then the integral of y squared, using the power rule, we add 1 to the exponent and we divide by the new exponent. So we're going to get y cubed divided by 3. Okay? And then this inside integral is going to be evaluated from y equals 0 to y equals negative x plus 8. And we still have the outside integral, but I'm not writing it because we're still simplifying this. Okay, so what we have to do now is we actually have to plug in negative x plus 8 here. So plugging in for y, we're going to get x squared times negative x plus 8 plus negative x plus 8 quantity cubed all over 3. Okay? And then we're going to subtract the whole function evaluated at 0. So that's going to be minus x squared times 0 plus 0 cubed over 3. Okay? But all this over here is just going to become 0. So this all becomes 0. And then we have to simplify all of this. So we're going to go ahead and distribute the x squared right here. So that's going to give us negative x cubed plus 8x squared. And then over here, we need to expand this polynomial. So the way we're going to do that is first we're going to do it by FOIL, and then we're going to distribute. Okay, so this is the same as negative x. Well, instead of negative x plus 8, you could write 8 minus x, but then you don't have the highest powers first. So we'll leave it as negative x plus 8. So this is going to be negative x plus 8 times negative x plus 8 times negative x plus 8. Because a cube means you multiply it times itself 3 times. Divided by 3. Okay. And here to multiply this out, we can use FOIL for these first two terms, for these first two factors. So here we're going to do FOIL. Okay, and if we do FOIL for those, we're going to get negative x times negative x is positive x squared, minus 8x, which is minus 16x, plus 64. So we have x squared minus 16x plus 64 times negative x plus 8 all over 3. Okay? And then we still have the negative x cubed plus 8x squared out front. Okay. And then what we can do here is we can actually multiply this out by basically distributing. So if we distribute the negative x to each term there and distribute the 8 to each term here, we can expand that. So we're going to have a lot of terms. So we're going to have a negative x cubed, and then we're going to have a positive 16x squared, and then a negative 64x. Okay, and then we're going to have plus 8x squared minus 8 times 16. I don't remember what that is, so I'm just going to use a calculator. So 8 times 16 is 128. Okay, so we have minus 128x plus 8 times 64. I also don't know what that is. So I'll go ahead and use a calculator. So 8 times 64 is 512. Okay, so we have plus 512. And by the way, you could have done this whole integral with with horizontal cross sections. We did vertical, but you could also do horizontal cross sections. but I think that would be about the same amount of work. Yeah, it's just a lot of algebra multiplying this all out. Okay, but this is actually the hard part. Just the algebra is the hard part of this problem. The rest of it's not as bad as you think. Okay, so now we can just combine like terms. So combining like terms here, we've got the negative x cubed. So there's two of those. So that's going to give us negative 2x cubed. Okay. So we've got a negative 2x cubed. And then we've got 8x squared plus 16x squared plus 8x squared. So that's going to be 24x squared plus 8x squared is 32x squared. Okay, so we have plus 32x squared. Okay, so that's taking care of all the x squareds. And then we have the x's. So negative 64x minus 128x. I should probably be able to do that in my head, but I'm just going to use a calculator. So 64 plus 128 is 192. So we have minus 192x. And then we have plus 512. Oh no, I made a mistake here. This was all supposed to be over 3. This was all supposed to be over 3, so I made a mistake here. So what I should have done is written this all over 3. I don't know why I forgot about that. I guess I'm tired. But yeah, all this was supposed to be over 3. So that means my x cubed and my x squareds are not correct here. So let me fix those real quick. So we've still got a negative x cubed here and a plus 8x squared. Negative x cubed plus 8x squared. All right, and then in here, this is all over 3, so that's fine. But then we're going to have to combine like terms. So this stuff here is kind of wrong. So as you can see, this stuff can get kind of messy. But what we got here is we've actually got a negative 1/3 x cubed right there. And then we have plus 16/3 x squared, and so forth. So if we want to make this whole thing a lot easier, we might just go ahead and factor out a 1/3 from the whole thing. Actually, that's what I'm going to do. Okay. So we'll factor out a 1/3 from the entire expression, just to make all these like terms a lot easier to combine. So if I factor out a 1/3, then I need to compensate for that by putting a 3 here and a 3 there. Okay, so that's going to give us a negative 3x cubed plus 3 times 8 is 24x squared. And then we have minus x cubed plus 16x squared minus 64x plus 8x squared minus 128x plus 512. And obviously if you have a calculator that will do polynomials like this, it could save you a ton of time. But I'm just doing it by hand because some people don't have those calculators. Okay. But I factored out a 1/3 just so that we can combine these like terms finally. So let me zoom out, and we're going to go ahead and combine like terms. So let's see, what do we got here? We've got negative 3x cubed and negative x cubed. So combining those, we're going to get negative 4x cubed. Okay? And then 24x squared, 16x squared, and 8x squared. So 24 plus 16 is going to be 40x squared, plus 8 is going to be 48x squared, right? Yeah, so we have plus 48x squared. Okay, and then we have the x's. So we've got negative 64x minus 128x. That's still going to be negative 192x. And then we have plus 512 at the end. But now we have a 1/3 out front. Okay, and I think that's pretty close to what they had. Yeah. Okay, so we should be good now. Okay, so that was a lot of extra work, unfortunately. But we're doing okay here. All right, so, but don't forget we still have the outer integral to do. So the outer integral was dx. So the integral from x equals 0 to x equals 8, dx is still our outer integral, and we still have to do that. Okay, so integral from x equals 0 to x equals 8, dx. So I can bring the 1/3 out front. Okay, and then we can just go ahead and use the power rule for all these terms. Y is constant, but that's okay because we don't have any y's. So plugging in and using the power rule, we've got negative 4x to the 4th divided by 4 plus 48x cubed divided by 3. So remember, with the power rule, you just add one to the exponent and then you divide by the new exponent. And then we have minus 192 x squared over 2 plus 512x. Okay, so that's just using the power rule, and we're evaluating this from x equals 0 to x equals 8. Okay, and then we can simplify this. So the 4's cancel, and then 48 divided by 3 is 16. And then 192 divided by 2, I don't know what that is. I should be able to do that in my head, but I'm lazy. So 192 divided by 2 is 96. Okay. Okay, so here we have minus 96x squared. Okay, so now we're ready to go ahead and plug in these numbers. So starting with the top number, we plug in 8 everywhere we see an x. And we still have a 1/3 out front. So we're going to have negative 8 to the 4th plus 16 times 8 cubed minus 96 times 8 squared plus 512 times 8. Okay? And then we can subtract all this evaluated at 0. But since every single term has an x, all these terms, when we plug in 0, they're all going to become 0. So we're really just subtracting 0 here. Okay? All right. So then this might be good to do on a calculator. 8 to the 4th sounds like a lot of work. So let me go ahead and do a calculator. So 8. Let's see, how do I do it on this one? 8 to the 4th. That's not how I do it. 8 to the 4th. 4,096. Okay. So here we have negative 4,096. And then we have 16 times 8 cubed. Okay, so 8 cubed is 512 times 16 is 8,192. So we have plus 8192. Okay, and then 8 squared is 64. So then we're going to do negative 96 times 64. Okay, so 96 times 64 gives us 6144. So we have minus 6144. And then we have plus 512 times 8. I think that's going to be 4,096 or something. I don't know. 512 times 8, 4,096. Okay, so we have plus 4,096. And then minus 0 doesn't do anything. Okay. And we still have our 1/3 out front. So this is a very messy problem that we're working on here. Taking a long time. Okay, but now we can add all of these. Okay, so let's do, let's combine all these. So we've got 8192 minus 4096 minus 6144 plus 4096. And that gives us 2048. And then we have to divide that by 3. Okay, so we have 1/3 times 2048. And then 2048 divided by 3 is not even a number, so we can't divide 2048 by 3, so we just leave it as 2048 over 3. Okay, so our final answer is going to be 2048 all over 3. Wow, that took me a long time. Mostly the algebra was annoying there, and I made a mistake, so. But fortunately, you only have one of them that's like this on your homework with a triangle. Okay, and then I think we should be good for the triangular ones now. Even though there's only one on your homework, as you can see, it's a lot of work. Okay, and then I just wanted to do one more. Okay, so one more example. Okay, so example. Given the integral, this one's a double integral from negative pi over 4 to pi over 4, and from 0 to cosine of t. We're integrating 4 secant of t, du dt. Sketch the region. Okay, so sketch the region of integration. And they also want you to evaluate the integral, but I think I'm going to let you evaluate it in your homework. Here I just want to focus on the sketch part because the sketch part's a little confusing. So they want you to sketch the region of integration in the TU plane, which is just kind of strange. In the TU plane. So the actual integral is a bit of work. Although it's not as hard as the last problem. But I just wanted to focus on the sketch because that might confuse people, so I wanted to show you. So what does TU plane mean? Well, it actually isn't as scary as you think. It doesn't mean that much. It's just like the XY plane. So the first variable is the same as x, and the second variable is the same as y. Okay, so this is like the xy plane. So you can kind of think of x as being like t as your independent variable, and y is like u as your dependent variable. Okay, so for your sketch, your horizontal axis, instead of being the x-axis, is now going to be the t-axis, and your vertical axis, instead of being the y-axis, is going to be the u-axis. And when they say sketch the region of integration, they really only mean you need to look at this stuff right here. You don't actually have to look at the 4 secant of t because that's inside of the integral. What you have to look at is this integral and that integral. So this is a double integral, and the inside variable is du, and u is like y. Okay, that's your vertical axis. So since the inside variable is u, which is like y, that's going to be vertical cross sections. Okay, so our inside integral is in terms of u, so that's going to be vertical cross sections. Okay, so when we're doing this, I'm not actually going to do the full integral. I'm just going to set up the drawing. Okay, so what's the sketch going to look like? Well, the outer integral is actually easier to start with here because it's going from negative pi over 4 to pi over 4 dt. So on the t-axis, which is the horizontal axis, we're going from negative pi over 4 to pi over 4. Okay, but then on the u-axis, that's where we have to go from 0 to cosine of t. Now how do I know this? Well, the inner integral is in terms of u, so it's going from u equals 0 to u equals cosine of t. And the outer integral is going from t equals negative pi over 4 to t equals pi over 4. We know it's like this because the outer integral is dt. Okay, so now we have to sketch u going from 0 to cosine of t. Well, 0, for u to be 0, that's just the line y equals 0 or the line u equals 0. So that's just a horizontal line. But then we have to sketch cosine of t. Okay, so what does cosine of t look like? Well, remember, cosine of 0 is actually 1. So this is going to be 1 right here for our cosine of t. And then remember that cosine of pi over 2 is actually 0, right? Cosine of pi over 2 is 0. So cosine of pi over 4 is actually going to be root 2 over 2. Okay, so cosine is going to be going down like this to here. And then cosine of negative pi over 4 is going to be negative root 2 over 2. I'm sorry, also it's going to be positive root 2 over 2. I don't know why I said negative. Okay, so on the u-axis, that's going to be root 2 over 2. Okay? So the trickiest part is just setting up what it looks like. But looking on MyMathLab, it looks like we have the right sketch now. And if you don't remember what your trig functions look like, you can always look online for graphs of different trig functions. And it is multiple choice for the sketch. Okay? But this is what our region of integration is going to look like. Region of integration. All right, and then I'm not actually going to do the integral here. But to do this integral, obviously you want to do the inside first. So you integrate secant using the formula for the integral of secant. And that formula should be on your Calculus 1 and Calculus 2 formula sheet. And then you're going to plug in cosine of t and 0 for u. Okay, so I'll let you do that in your homework.